going over homework 2. In homework 2, it just asks us to go ahead and write a C code that deals with multi-threading. Essentially, we're going to be generating 100 threads to see if we can find a prime number. Each thread is going to give like 10 attempts to do so. So I'm just going to go ahead and show you how I did it. And so this is the assignment of what it wanted to do. We did to generate number generators for to see if the for each thread, so it can see if it's a prime number. Gets out most to 10 attempts, and then this is what it's supposed to look like at the end of it. This is just an example of 30 threads. I'm going to do 100, and this is the max tries is to be 10. And you can see that each thread, it just says it's either no, they didn't find no prime numbers after 10 times, or and once they did find a prime number, they did return it. So I'm going to go ahead and show you what it looks like. This is my, make it a little bit smaller here. This is my code in the HPC. I just called it I call it homework 2. And so essentially originally I was working on my local machine, which I have a Mac, and I didn't need this, but because it's HPC I couldn't install packages, so I had to include an if statement to check if whether I'm on an Apple device or Linux. If I'm Apple, you can just use this command or this include, but if not, if I'm on Linux, just go ahead and use this. And this is just to reassure that the code will work regardless if it's an Apple, Linux, or if it's neither, it will just run this. Okay, so let's go ahead and just show what it shows here. Already for the random generator, I have a function called random bytes, and here we just pass in the buffer and then the length. This is essentially a helper function. This is just supposed to assist us with filling in the buffer with random bytes with the exact number of lens, because we needed to do that when we're going to call the generator. And I'll show you where we call this. So let's go ahead and get started. Num threads is the number of threads that I'm going to be generating, okay? And then this is the number of tries I've set it to. So I've set it to 110. I could change this, and it doesn't matter. This max val essentially represents our upper bound. So we just have it to be this many 9s, and then UL, which is the type, the unsigned long. And here, this is just an array for us just to keep track to see which thread was prime or not. So if we put a 0, that means the prime couldn't find that prime number, which is kind of comparable to what was shown in the example. But if there was a 1, then that means we were able to find a prime number, and so that's good. And we'll be using that later. This is the random generator. This is me. So these are just me declaring the functions. I haven't called them or I haven't defined them yet. So this is, I'm going to have a function called random generator. I'm going to have a function called is prime. I'm going to have a thread function. So and I'll go through what they are when I actually, let's just do it now. So for the random generator, the point of it, it's supposed to generate a random number with the type of unsigned long. So by the end of it, each attempt that the thread makes will generate a number. And so this is how it does it. We're going to assign a variable called toTest, which is the unsigned long, and then we're going to go ahead and call this random bytes. Remember, that looks kind of familiar, and that's because if we go back up, it's right here. It's where we this is our helper function to help us fill in that buffer. Now, down here, back to the random generator. Once we get that, we fill in the random by filling with the random bytes. We will go ahead and now we're gonna get the toTest that we've defined earlier. we're going to assign it to doing the modulo of to test of a max val. And the point of this is just to limit the maximum random value, just so we don't want it to go like past the limit that we have set. And then finally, we're gonna just make sure, again, the point of this code is to see if something is prime or not. And so we know, like 2 is the smallest number we can get as a prime number. So ignore if it's a 0, 1, and obviously negative numbers are not prime either. So first we're just doing a little safety check to make sure that the to test is at least a number between, at least a number 2 and above, which it is, and then we're going to go return it. Now remember, this random generator, we're going to use it in our later down, and the idea is that for every attempt the thread happens, it generates a random number to see if it's prime. If it is, it'll exit out early. But anyway, so with this function here, is prime is basically a function that returns a Boolean value, and if it will tell you true if it's a prime number. If it's false, that means it's not a prime number. So there are a couple of like early conditions I wanted to set. So automatically, if it's less than 2, then the number isn't prime, because remember, 0 and 1 are not prime, and nor is a negative number. However, if it's exactly 2, then yeah, that's the only prime number, like the lowest prime number it can be. Other than that, this is us testing to see whether if it's a prime number or not. So we just do the num, which just gets passed in, do the modulo of the 2, and set it. If the remainder is equal to 0, then that means it's not a prime number, because that means it's even. And then finally, so by the end of it, we wanted to use brute force to detect if it's actually a prime number, because that's what the instructions stated. They wanted us to use brute force. And so we're going to start with 3, because we've already dealt with early conditions of 0, 0, 1, and then 2, and then if it's an even. Now, here is us doing brute force. So when we enter the while loop, it only enters when a divisor is timing itself if it's less than or equal to the num. And once it enters the while loop, it checks this if statement. The if statement to see if the num is a modulo of divisor, and if its remainder is 0. Now, if it's true, it will just keep ignoring this. But if it's false, then it's gonna exit out the while loop, and which means the number is not prime, and that means because there's a factor found, so it was an even number. But assuming if this wasn't the case, if statement wasn't the case, and it continued, it's going to get the divisor and it's going to plus it by 2, because that's how you get the next odd number, and then it keeps going into the while loop and until there is a part that it found something. So anyway, after entering the while loop and exiting, if there was none of the factors that was found, then it was prime. But if it's prime, that means we want it to return true. But if it returned false instead, that means it was an even number and it found a factor. So that's it for the is prime. And then now with this thread, this thread is like one of the worker threads, and so the aim of this function is just to check to see if the getting the random number from the generator, and then evaluating, see if it's actually a prime number. So we're gonna call those two. You'll see where they're being called, and then if it is a prime number, it's gonna store it at the array's index, and if the random number is not prime, then it will store 0. But and remember that each thread can only get like max 10, since we defined the max tries to be 10. So let's just go into the thread function. We're gonna go ahead. This int ID is getting the thread ID, essentially really the index of the thread out of that pointer array that we created, and then we're gonna automatically have a found for a boolean and just set it to false. Then we're gonna go ahead and just get a thread underscore prime num, and then for each thread, this is where we're gonna only allow it to do 10 times to check if it's a prime number. And so when we enter this for loop, for each thread, it's gonna generate a random number by calling the random generator, and then it's gonna check the prime, if the random number is prime. Now, if it is prime, then we're going to say, hey, found is true. And then we're going to store that number into thread prime num. And then we're going to break out. And then that means we found a prime number. But if we didn't, then we would, again, remember, store 0. Well, here's where it says, it reads whether the found variable is true or not. So if it was true, that means we did find a prime number. And if we find a prime number, then we're going to set that prime num, and we're going to set it to the result of, we're going to set it to the index of that thread in results. Okay, and then, but if we didn't, we're just going to store 0. And remember, at the end of it, if it's 0, that means it wasn't prime. But if it's another number other than 0, that means there was a prime number, and that is the prime number. And then it's going to exit out, which is thread. So how does this get put together? Well, let's take a look at main. So right here, this is our main function, where we're going to call all of the functions that I just explained to you. So this is where we actually have an array of threads, and we're going to specify the array of threads with the num thread that we've defined up and top earlier. Then this is the array of thread IDs, and this is just a safer way for us to tell whether there was a prime number found for that thread. And then at the end, I just wanted to say that in the thread we right here, I did have to use the pointer arguments to extract the ID or the index of the thread. I wanted to mention that. And so let's go back to the main method. Alrighty, so this is me right here doing a for loop. We're just initializing each element to 0. So that means basically at already given start, none of the threads found a prime number, which is true. This is going to get updated later, as you can see. And this is me initializing that results, which is right here. Now we're going to go ahead and create all the threads. And this is me creating all the 100 threads by assigning the ID, creating the thread using thread, pthread underscore create, passing the respective arguments it needs, where we pass to the reference, it passes, and then we're going to do null. By using null, we're just setting it to the default thread attributes, then passing the thread function and the thread ID. And then we're going to, in case if it's not 0, that means it's something went wrong on creating it. And so we needed this like safety check, so it doesn't mess with our code. But when it's not 0, that means thread was created safely, which is great. And then we're going to join all the threads that was already created, and this is the safe way to fail. And then where it's going to exit, return 1, and this is safely exits our program, in case it wasn't able to create the thread during the run of that program. So then finally, that's just a little safety check. Now here we're doing the for loop, and this is where the main thread waits for all the threads to finish running its task, and then we're gonna go ahead and print the results. Depending on what the index is, if it's set to 0, that means we didn't find a prime number. But if we didn't, then let's go ahead and print the thread ID and the prime number at its respective index, and then that's it. So let's go ahead and show you how it's run. So I'm going to compile, and there you go. That's what it looks like at the time of the run. That's 100 threads. Alright, thank you.